Okay. Again, you're going to notice at the very top right corner, you see the learning goal for the day. It's there on your sheet of paper. Describe the two-dimensional figures that results from slicing a three-dimensional figure. You've actually done some of that. If anybody that's ever cut an orange apart, you've taken a slice of a three-dimensional figure. When you cut an orange, what shape is the face when you cut it? It's a circle. I mean, you could certainly make it a semicircle if you cut it again, right? But that's what they're talking about. What would it look like if you actually took a three-dimensional figure and could take a slice out of it? And how can we identify those cross sections? So, if you'll take a look, an intersection is a point or a set of points common to two or more geometric figures. A cross section is an intersection of three-dimensional figure and a plane. What you need to know is they're not talking about an airplane. A plane is a two-dimensional shape that is infinite in length and infinite in width, but actually has no thickness. It's one of those undefined terms because technically, could we draw a plane?
We could.
Technically, can I draw something that's infinite in length, infinite in width, and has no thickness? I can draw something that represents it, but could I actually draw a plane? No. In fact, if I took just a single sheet of paper, if I could extend it infinitely this way, the sheet of paper might make a good representation, but what's wrong with it? It has thickness, right?
Yeah.
So a plane really doesn't have thickness. We represent it usually by drawing something that looks a little bit like a rectangle or a parallelogram.
Are plane basically kind of like a big grid?
A plane is, yes, like a big grid. It's like your top of your table. Literally, the top of your table has, if you're looking at just the top has no what? No thickness, if you're just looking at the top. But how far would it go to your left? Infinite. How far would it go to your right? How far would it go in front of you? Behind you? We can represent a plane, but can we actually draw it? No.
Air is a plane.
What's that? That's correct. You can't even see an actual plane. That's correct. Okay?
Wouldn't air be a plane? Like the air?
No. Air would be space. Air is actually space. When you're starting talking about three dimensions that are infinite length, width, and height, that's air. And so it's space.
What about gravity?
That's something different. That's force. Okay? That's space. That's what it is. It's three dimensions. A length, a width, and a height that's infinite in all directions. So, let's go back to this cross-section idea. They said if I take a plane and I slice it through a three-dimensional object. So, what shape is the one that's here? The three-dimensional figure. What shape is it? It's called a cone. Okay? And when I take a plane through a cone, what shape is formed? A circle. Okay? They're talking about where it actually intersects.
Oh!
You see where it intersects? It's circular. Can anybody tell me what would happen if instead of passing it straight through, parallel, if I kind of angled it up through, what shape would it be then? Would it still be a circle or would it be different?
It would be an oval.
It would, in fact, be an oval. Okay? If I angled it through, other than making it parallel with the base, it would be oval in shape. So that's what we're talking about today. How to identify what that piece is going to look like when a plane is passed through it. This, does anybody know what shape the original 3D object is? It is a triangular prism because the base is triangular shaped and It has two bases that are the same, so it's a triangular prism. They pass the plane through it. What's the intersection? It's a triangle. Everybody understand what we're doing? So, with that being said, let's take a look at A and B that are there on that first page. Okay? They're asking you to identify, they're drawing the intersection, they're asking you to identify what that cross section actually is, where it intersects. So the original shape here was a rectangular prism, and they took a plane and passed it through, but they didn't pass it through parallel to one of the bases, did they? They kind of knocked off a corner. What shape is the piece that's going to be cut off? That's all they're asking you to do. Identify that piece. Okay? Identify that piece. This was also a rectangular prism, but this time they passed it through. What can you tell me about this one?
Rectangle.
It's a rectangle.
Oh my god, this is so easy. This is the hardest thing ever.
Okay. Let me just ask a quick question. What can you tell me about this rectangular shape in B compared to its base? They're the what? Same. They would in fact be exactly the same. Everybody okay?
Yes.
Let's look at C and D.
Oh wait, is there gonna be like parallelograms?
Let's look at C.
Oh, I can already see our homework.
Let's look at C. Here they took a rectangular prism, and instead of passing the plane through parallel to the bases, they angled it. This shape that's in here, what is it going to be? It's a parallelogram. It's a parallelogram.
And the other one's a square. No, it's not. It is a square.
If this is a square on the end, then this one is also going to be what? A square.
Jeez, that's confusing. Oh wait, okay. Tell me if I'm right.
Any questions about this so far? Yes.
Well, I was just saying, so it did go straight through, and the shape maybe look different, but if it goes straight through, then it'll be the same.
It's going to be the same as the base if it's a prism. Okay? I would say that this is square in shape. And what it is its perspective in how you're looking at it. And I can tell you that one of the problems that you run into dealing with three-dimensional shapes is the fact that this is always kind of fun. So let's do this real quick.
Dylan, stop passing notes.
Please stop. One of the problems of dealing with three-dimensional shapes is we're drawing three-dimensional shapes in a two-dimensional space. Okay. So, listen. This is what I want you to do. I don't want you to do anything except stare at the picture. Just stare. I want you to look at just the picture. Don't look at anything. Don't say anything. You're going to see something happen. Just stare at it. When you see it happen, don't shout out. Don't say anything. Let everybody have the same opportunity to see it. Just stare at it. I'm going to tell you it works on 98% of the people. Okay, just keep staring at it, and you'll notice it And if you don't notice it, you just fit in a group that doesn't see it.
Wait, what happened?
Just keep staring at it. Don't do anything else. Don't talk. Don't do anything else but stare and literally stare at the picture.
This is trippy. Whoa, what?
Just happened, didn't it?
What?
Listen. The problem with dealing with three-dimensional figures in a two-dimensional space is the fact that when I draw this, you can't really tell what's the front, the back, the left, or the right, can you? Because as you're looking at it, what happens? It changes. Now, it obviously doesn't change. What happens is, whether you realize it or not, is you might blink, but where you're focusing changes ever so slightly. And when that happens, that image flips on you. So it's really difficult working with three-dimensional figures in a two-dimensional space because of that. But you get the concept? Did it flip on you? Then you're one of those oddball people that it doesn't flip on. Okay? Okay. But if you stare at it, to me, right now, this square kind of looks like the front. But if I stare at it long enough, that'll no longer look like the front. Something else will.
No, I just drew it and it still works.
That's correct. And the reason, again, the reason it works on a small sheet of paper, the same as it does up there, is because whether you realize it or not, where you're focusing changes ever so slightly. And it makes that object flip. If you stare at it long enough, it'll literally make you dizzy.
Wait, I forgot how to make these things.
Okay.
No,
Okay. We'll come back to it. Turn to the next page. Please. It's on the same page? Okay. In a right pyramid, the point where the triangular sides meet is centered over the base. Okay? So they're saying that this is exactly centered over the base. Okay? The shape of the base is what? It's a square. The shape of each side is what? Triangle. Is it possible for a cross-section of a pyramid to have each of these shapes? Can I get a square? Yes. Could I get a rectangle? Yes or no? I could. Could I get a triangle?
Yes.
Could I get a circle?
No.
Could I get a trapezoid?
Yes.
Okay? Listen. If they ask you to sketch something, all I'm going to ask you to do is try to sketch it. Do I expect your sketches to be perfect?
Yes.
There's no way. And I'm going to tell you that it really helps when you're making a cross-section if you highlight the piece where it intersects. I'd have the unique ability that the pictures that I take are highlighted just like your book is, right? So, I'm going to tell you that cross-sections are easier to see if you have a way to shade that piece where its cross-section meets. Your assignment today is page 83 and 84, 1 through 11. Okay?
11.